Imagine yourself floating in the darkness between Saturn and its rings. Not on the planet itself, but suspended in that narrow gap that scientists once believed was empty, peaceful, serene. You're suited up in the most advanced spacecraft humanity has ever built, threading through a space barely wide enough to fit. Above you, the rings stretch across your entire field of vision, a shimmering highway of ice particles 175,000 miles wide, but somehow only 30 feet thick in places. Below you, Saturn's atmosphere churns in amber and gold bands, each one wider than Earth itself. You came here expecting silence, emptiness, a void. But that's not what you find. Instead, you're flying through a storm. Particles are raining down around you, streaming from the rings above like a ghostly waterfall. Cascading into Saturn's atmosphere at impossible speeds, your instruments light up, screaming warnings. This isn't ordinary ice. This is ring rain, and it's falling at a rate that shouldn't be possible, carrying with it chemicals and compounds that scientists never expected to find. Every half hour, enough material to fill an Olympic swimming pool drains from these ancient rings into the planet below. Saturn, the crown jewel of our solar system, with its majestic rings that have captivated humanity for centuries, is doing something deeply wrong. Its rings are dying, and they're dying fast. I'm Richard, and you're watching EW Universe. Join me today as we dive into one of the most shocking discoveries in modern planetary science. We'll explore how scientists uncovered this cosmic catastrophe. We'll investigate the mysterious forces destroying Saturn's most iconic feature, and understand what this celestial death sentence tells us about the fragility of even the most spectacular structures in our solar system. Because here's the terrifying truth. We're lucky to be alive right now. In cosmic terms, we just happen to evolve during the brief window when Saturn has rings at all. When you picture Saturn, you picture the rings. They're inseparable. As iconic as Jupiter's Great Red Spot or Mars's rusty deserts. But what if I told you that Saturn hasn't always looked like this? And more importantly, what if it won't look like this much longer? For 400 years, since Galileo first pointed his primitive telescope at Saturn in 1610 and mistook the rings for ears on either side of the planet, once we've assumed these rings were eternal, ancient, born with Saturn itself, 4.5 billion years ago when our solar system formed from a swirling disk of gas and dust. We were wrong about everything. In 2017, NASA's Cassini spacecraft made its final, suicidal dive through the gap between Saturn and its rings. The mission was designed as a dramatic finale, 22 death-defying orbits through territory no spacecraft had ever dared enter. Scientists expected interesting data. What they got shook planetary science to its core. The rings weren't ancient, they were babies. Maybe 100 million years old, 150 million at most. Saturn is 4 billion years old, but its rings showed up just 100 million years ago. To put that in perspective, when Saturn's rings formed, dinosaurs still walked the Earth. A T-Rex could have looked up at a naked, ringless Saturn in the night sky if it had been smart enough to build a telescope. The evidence was overwhelming. Scientists measured the rings' mass by watching how their gravity tugged on Cassini. The rings weighed in at only 0.4 times the mass of Saturn's moon Mimas, far less than expected. They were too light to be old. Just like a bookshelf in your house, objects in space accumulate dust over time. Clean, pure ice exposed to billions of years of micrometeorite bombardment should be dirty, contaminated, darkened. But Saturn's rings were pristine, impossibly clean, shockingly bright. The rings weren't just young, they were dying, and Cassini was about to discover exactly how. So what's killing Saturn's rings? And why would ice particles suspended in space simply decide to fall? The answer involves a phenomenon so bizarre that scientists initially thought their instruments had malfunctioned. As Cassini threaded between the rings and the planet during those final 22 orbits, an instrument called the ion and neutral mass spectrometer began detecting something impossible. Material, lots of it, streaming down from the rings into Saturn's upper atmosphere like a constant downpour. This is the first time that pieces from Saturn's rings have been analyzed with a human-made instrument, said Sasha Kempf of the University of Colorado. If you had asked us years ago if this was even possible, we would have told you no way. But the data didn't lie. The rings were raining onto Saturn between 4,800 and 44,000 kilograms per second. Let me put that in perspective for you. Every 30 minutes, enough ring material falls onto Saturn to fill an entire Olympic-sized swimming pool. The rings aren't just eroding slowly over eons, they're hemorrhaging mass at a catastrophic rate. Picture this. You're standing under a water tower that's slowly leaking. At first, it's just drips. Annoying, but manageable. The tower will last years, maybe decades. But then the leak accelerates. Suddenly it's a stream, then a pour, then a torrent. That's what's happening to Saturn's rings right now, and we just happen to show up with cameras to watch it happen. The mechanism is elegant in its simplicity and terrifying in its inevitability. Saturn's rings are made of water ice particles ranging from dust grains to house-sized boulders. They're caught in a delicate balance. Saturn's gravity pulling them inward, while their orbital velocity flinging them outward. For most particles, this balance is stable. They could orbit for billions of years, but then the sun gets involved. Ultraviolet radiation from the sun strikes these ice particles and electrically charges them. Think of it like rubbing a balloon on your hair. The particles pick up a charge, just tiny, static electricity at the cosmic scale. But here's where it gets deadly. Once charged, these particles suddenly feel the pull of Saturn's enormous magnetic field, which curves downward, pointing directly into the planet's upper atmosphere. It's like the particles have been given a death sentence. Picture iron filings near a magnet. They don't have a choice anymore. They can't resist. The magnetic field lines act like invisible rails, and gravity slides these charged particles down those rails straight into Saturn's atmosphere, where they vaporize at temperatures exceeding 150 degrees Fahrenheit. The ring rain wasn't just water. That's what shocked scientists most. When Cassini analyzed the chemical composition of this falling material, it found something unexpected. The implications were staggering. Silicates shouldn't be in ice rings. Their presence suggested something violent in Saturn's past. These weren't primordial rings that formed alongside the planet. These were the shattered remains of something else. Maybe a moon torn apart by Saturn's gravity. Maybe a comet that wandered too close. Whatever it was, it died violently. Computer simulations run by NASA scientists in 2023 painted a chilling picture. About 100 to 150 million years ago, 2 of Saturn's icy moons were pushed into an unstable orbital resonance. Think of a parent pushing a child on a swing. Small, rhythmic pushes, timed perfectly, can build up enormous momentum. The sun's gravity acted as that rhythmic push, slowly elongating these moons' orbits over millions of years until their paths finally crossed. The collision was apocalyptic. 2 moons, each potentially the size of one of Saturn's current moons, smashed into each other at orbital velocities. The impact shattered them completely, ejecting debris across Saturn's equatorial plane. The heaviest pieces, rich in silicates and rock, spiraled inward and were consumed by Saturn. The lighter, icier fragments spread out, forming the magnificent ring system we see today. Scientists even gave the hypothetical destroyed moon a name, Chrysalis. Like the insect's cocoon, it was a temporary structure. It existed for billions of years before its violent transformation created something beautiful but fleeting. So how much time do the rings have left? When will Saturn become naked and unremarkable? James O'Donoghue, lead scientist on the ring rain study at NASA Goddard, didn't sugarcoat the answer. The rings have less than 100 million years to live. Read that again. Going less than 100 million years. In human terms, that sounds like forever, but in cosmic terms, it's an eye blink. Saturn is 4 billion years old. It will live for billions more. The rings existed for just 2.5% of Saturn's past, and will be gone before the planet reaches middle age. We're watching them die in real time, and it's happening from multiple directions at once. The magnetic field is dragging charged particles down from the rings. But there's another drain scientists discovered using the Keck Observatory in Hawaii. Ring material is also falling onto Saturn at higher latitudes, pulled down through different mechanisms. When you add into Saturn's equator, and the rings have less than 100 million years to live. Less than 100 million years. That means if you could travel forward in time to the Cretaceous period, when dinosaurs ruled Earth, and look up at Saturn through a telescope, you wouldn't see rings. The planet would look plain, boring, unremarkable. Then somewhere around the time of the dinosaurs' extinction, catastrophe struck Saturn's moon system. Chrysalis died, the rings were born, and now they're dying again. Think about the cosmic luck required for us to be here right now watching this. If humans had evolved 200 million years earlier, we would have looked up and seen a ringless Saturn. If we evolve species descendants who survive another 200 million years into the future, they'll never know what Saturn looked like in its glory days. Earlier this year, on March 23rd, 2025, something eerie happened. Saturn's rings vanished. Not metaphorically, not gradually. They literally disappeared from view for observers on Earth. This phenomenon, called a ring plane crossing, occurs every 13 to 15 years when Earth's orbital position aligns perfectly with Saturn's ring plane. Remember, the rings are only 30 feet thick in some places. Seeing them edge on from Earth is like trying to see a sheet of paper from across a football field. They're still there, but they become invisible. Galileo witnessed this in 1612, 2 years after first discovering Saturn's ears. When he looked again and found them gone, he was baffled. "What is to be said concerning so strange a metamorphosis?" he wrote. Well, the mystery haunted him until his death. We know better now, but the March 2025 disappearance carried a different kind of weight. It was a preview, a glimpse into Saturn's future. Because one day, perhaps 80 million years from now, perhaps sooner, the rings won't disappear because of viewing angles. They'll disappear because they're gone, consumed entirely by the planet they once adorned. But Saturn's story stretches far beyond one planet's aesthetics. It's teaching us something profound about planetary systems everywhere. Firstly, we've learned that spectacular features in space are often temporary. Jupiter has faint rings, so do Uranus and Neptune. Scientists now believe those planets might have once sported ring systems as magnificent as Saturn's, but we missed them. They already drained away billions of years ago. Well, we're just lucky enough to exist during the brief, beautiful moment when Saturn still has its crown. Secondly, and perhaps most hauntingly, the destruction of Chrysalis and the creation of Saturn's rings might have fundamentally altered the planet's entire moon system. The collision didn't just create rings, it may have created some of Saturn's current moons, including Enceladus, the tiny ice world with liquid water oceans beneath its frozen crust. One of the most promising places in our solar system to search for alien life might only exist because of a catastrophic collision 100 million years ago. Finally, Saturn's rings are teaching us about the violent, chaotic nature of planetary systems. We used to think the solar system was stable, ordered, predictable, but Saturn's rings are evidence of recent catastrophe. Moons can die, planets can be scarred. Even the most beautiful structures in space are temporary, fragile, and fleeting. If Saturn's rings can form and dissolve in just 200 million years, what else in our solar system is temporary that we assume is permanent? What other cosmic structures are we seeing at just the right moment before they vanish forever? NASA's Cassini spacecraft made its last transmission on September 15, 2017, as it burned up in Saturn's atmosphere. In its final moments, it was still collecting data, still analyzing the ring rain, still working until the very end. The spacecraft had spent 13 years orbiting Saturn, watching the rings from every angle, discovering their secrets, witnessing their slow death. Future missions will return to Saturn. New spacecraft will watch the rings continue their slow fade. Now, scientists will refine their estimates, track the drainage rate, measure how much longer the spectacle will last. But no future mission will see what Cassini saw. The rings will be smaller, thinner, dimmer, less magnificent. We're living in the golden age of Saturn's rings. In the entire 4 billion year lifespan of this planet, there's a 200 million year window when it looks like the Saturn we know and love, and we just happen to evolve our telescopes and spacecraft during that narrow cosmic instant. Saturn's rings are teaching us to appreciate the temporary, to photograph the fleeting, to marvel at beauty we know won't last. Because in the universe, nothing does. Mountains erode, stars explode, planets migrate, and sometimes, if we're very lucky, we get to watch something magnificent slowly fade away. Just knowing that our descendants will never see it in its glory. So look up, point your telescope at Saturn, show it to your children, your friends, anyone who will stop and stare, because the rings you're seeing won't be there forever. They're falling right now, every second, every minute, draining away into the planet they once orbited. In less than 100 million years, they'll be gone completely. The universe never stops changing. All we can do is watch while it lasts. Thanks for watching.